Hey everybody, welcome back to my YouTube channel. Today on Workshop Quick Take, we're going to be looking at a couple of options for portable video lights, both conventional and unconventional, anywhere from about $5 to $50. Now, if you think this doesn't apply to you, think again. We're looking at probably about a year of work from home and distance learning arrangements due to coronavirus. And that means that people who maybe haven't thought much about microphones or lighting in terms of video might want to start doing so, because part of an effective presentation or just communicating with your coworkers or students or teachers or whatever side of the camera you're on is making sure that you can be heard clearly, and then once you've verified that, make sure you can be seen. I'm currently at my workshop and the lighting isn't terrible. I have lots of bright overhead lighting for working, but sometimes it does leave a few dark spots on my face depending where I'm standing relative to the lights. If I move around a bit, it kind of shifts, and it could be a little better. Now, how do we make it better? You need lighting that's kind of off to the sides, and I'm not an expert on this, so don't come to me looking for how to set up your professional video shoot. That's not me. What I'm just going to try and give you is a couple ideas for things that you can buy at a reasonable cost that will allow you to more effectively present. So, if I remember correctly, the way you get changes in videos on YouTube is something like whoops, that didn't do it. Okay, one more time. There we go. Okay, now what just happened is I turned on 3 Harbor Freight flashlights that we're going to cover in this video. They have a magnetic base. I just stuck them to metallic objects that were convenient. And just like that, I have fill lighting around me that was reasonably easy and quick to set up, and is pretty easy to recharge as well. Now, there are cheap ways of doing it. There are more expensive ways of doing it. For example, okay, now I just added a small panel video light, which we'll also look at, and you can see that I'm getting a lot more fill light. The advantage of that is that in order to see me this clearly otherwise, I'd have to turn the exposure way up, which would blow out the background. But by adding fill lights around, you can kind of highlight your subject without darkening out or brightening out, whichever the case may be, your background settings. So that's really a useful trick to have. And just to give you an idea what we're looking at right now, straight in front of me is the Lumix, and then over to my left is a GoPro. So you're getting 2 quick little perspectives here on how I'm sitting relative to the camera and what effect the background lighting has had. This here is an example of a fairly conventional LED video light. This one's by Viltrox, of course, Neewer, and a couple others make these. You'll see these a lot on YouTube videos, especially like exploration videos, and they want something that's, puts out a decent amount of light, but is also cheap enough that you won't feel bad if it gets destroyed. This one here has a slot to take a Sony NP550 style, F570 style camcorder battery. These are very, very common now for these purposes. I think it's a 2-cell design. So you snap it in place, you turn your unit on, and just like that, you have your controls. In this case, brightness, or press to change color temperature. Let me turn the exposure down. So going to the red end, going up to the bluish end, and then of course brightness. It's, edge lit LED, it's alternating reds and blues. There's some other video light designs that actually have a grid behind here instead. This is a lot like how a laptop screen is backlit, but without the LCD sitting in front. And turned all the way up, it can put out a tremendous amount of light. But when you do that, this nifty little battery indicator here starts dropping fearsomely. So an alternative to that, if you're not going mobile and you just want to set this up on a tripod for doing some video work, is it does have an input. DC in, 12 volts, and if you look very closely at that symbol, what that means is positive center. Now the question is, what do you do for a 12-volt power source? Are you just going to go out and buy one on Amazon or whatever for 15 bucks? Well, there might be another way. First, let's see if we can get any clue at all about what that's supposed to be. Normally on electronics like this, there will be some sort of sticker indicating power consumption and all that, but on this kind of stuff, especially if it was Chinese direct import, who knows? But fortunately, this one was good enough to include an owner's manual, and it has a spec sheet. Input power 8 to 15 volts, maximum of 2.0 amps. Notice that next to the input power here, we have this little symbol phi, which is being used for diameter, 5.5 by 2.0 millimeters. This is the outside dimension of the barrel, and this is the inside dimension where the pin contacts. This is important to know because now that most things are being powered by USB, these little facts are being forgotten about how to order these things. But if you have to go to, say, Mouser or Allied Electronics or even just Amazon, you'll see a bunch of different specs for these. The way to do this is one of these two must be exact. If it's the outside diameter, then use 5.5 and that will keep the barrel from slopping around in the connector. Or if you go by the pin, make sure it's the 2.0 millimeter and the barrel will center itself on the pin. Then you can have a little bit of float on the other one if you have to. So for example, you decide to go with 5.5, then your inside diameter can be 2.0 or slightly larger. If you stick with the 2.0 millimeter inside diameter, then your outside can be 5.5 or slightly smaller. So before you go on to Amazon, take a look at your local thrift store. Sometimes you'll find an entire aisle of nothing but random power supplies, and there's usually a lot of 12-volt adapters out there, such as this one. Input 100 to 240 volts AC, universal power supply, okay. Output 12 volts at 1.5 amp, positive center. Now here's the kicker. They tend to have a fairly narrow range of power connectors, and one of these might actually be compatible with, oh, look at that. So, before we actively try and turn this on and see whether or not we get light or smoke, or both, let's go ahead and pull out our handy dandy Harbor Freight meter and just make sure that the power output on this power supply is doing what we think it's doing. And there's two tests we want to do to prove that. So I'm going to go ahead and start on volts DC with a 20 volt scale. And if this is doing what I hope it's doing, putting positive in the center and negative on the sleeve should give me a positive voltage reference. It does, and I'm seeing 12.14 volts. So let's just go now to a fairly sensitive AC scale, 2 volts. And let's just double check to make sure there isn't some sort of high AC noise signal on here which would indicate that the supply is failing. And it's not. It pretty well goes to 0. So short of getting out an oscilloscope, that's at least a pretty good sign that I've got a clean power signal on here. We know that this works with the battery installed. And now, to find out whether or not I have viable power supply or a burned out video light, I'm going to go ahead and plug this in. Nothing bad yet. Let's turn it on. Let's try going to 100%. And keep in mind that right here at 4400K where I'm set now is about midway between the cool white and the warm white, which means that both sets of LEDs are turned on. So turn that up to maximum brightness and see what I get. Still running. Let's try fiddling through the color range here. All the way down to 3300K, all the way up to 5600K. So there you go. There's a possible solution. If I'm just parking this on a tripod rather than constantly burning down my batteries, I can just use this. And this is something you can find at a thrift store for a couple dollars if you look around at a few. Let's take a look at one more supply. This is another one I found in the bin of spare power supplies. This one here outputs the full 2 amps that was recommended by the Viltrox spec sheet. So just to see what this one is doing, let's plug it in and apply the same multimeter test we were doing before. So there's our multimeter, and we'll just start on the same 20 volt DC scale and make sure that we are in fact getting positive on the tip like it says it's supposed to be doing, and negative on the sleeve. And look at that. Now granted, most of these switching supplies can be a little unstable unloaded, but this one is floating around just a little bit. But now let's go to the AC 2 volt scale and see what it looks like there. Look at that. That is not as stable of a supply. Now it's not going, very high for the most part, but I am rolling the dice a little bit here plugging this in. But hey, that's why you're watching, right? Let's give it a shot. Turn it on, and it's working. And I have a feeling that if we had access to this tip and sleeve on here now, we would be able to see a cleaner signal because some switching power supplies simply do not stabilize unless they have some load on them. So then, let's find out. I'm going to start by double checking our voltage again. Yeah, it's still wandering. And before I plug that in again, I will get a second meter. And just looking at the 20 volts DC scale, make sure I still have positive tip, negative sleeve. And I do. So now what I should be able to do is plug this into the light so that I've put a load on the power supply. Oh, would you look at that. Okay, that's interesting information. This here was rated 2 amps, but with a very modest load, it's having a hard time recovering its voltage, very slowly crawling its way back up. Well, just for fun, let's go back over to our AC volt scale and see what's happening. Oh my. Still getting about 0.224, 225 volts AC noise. I mean, that's quite a bit of ripple, considering it also lines up with the fact that the voltage dropped so far on the DC output. That kind of makes me suspicious that we've got a bad supply there. Just for fun, let's pull one of the others that was definitely working and see what it does. Plug in this one, which was definitely giving us a nice reading earlier. Still seeing a very nice 12.14. Very little AC noise. So plugging this in, switching it on. Yeah, that's actually good information. It tells me that other supply I had, the initial readings that looked a little spotty were in fact spotty. It's probably going bad. However, since I know that I've got a nice little cord with a plug adapter that fits, I can save this for a future DIY project. We'll talk about a possibility in a few minutes. Oh, what is that anyway? That looks to be about, that's saying 5.4 millimeters on the outer diameter. And, well, that just barely fits, so I want to say 5.4 millimeters outer diameter and maybe 2.4 on the inner, or something very close to that. But wait, there's more. Here's a third one I found, and interestingly, this one is only rated 1.25 amps on the output. So let's see what it does when it's plugged in. Didn't get any sparks from connecting it to the wall. Once again, I start with my Harbor Freight meter on the 20 volt setting and test it. And I like this one. It's actually giving a pretty stable voltage there, even unloaded. Let's take it over to the AC setting. Yeah, a lot less wandering on that one. It goes down to 0. Let's see what happens when it's overloaded, because this thing is in theory able to pull more than that 1.25 amps when it's at full brightness. Well, it still comes on. It's not acting up at all, so that seems to be a viable power supply also. So there you have it. Before you go spending money on yet another power supply on Amazon, see if you've already got one in your spares collection, or if you can get like a $2 one at a thrift store that will do the job just as well. Alright, here's a newer video light, and this is a slightly different layout than the Viltrox light we were just looking at, although it does use the same kind of edge-lit screen as before. And it also uses the same Sony NP550 or NP570 style camcorder battery. Once you plug in the battery, you pick your light intensity and you pick your color temperature. This one here has separate dials for both, but it operates pretty much the same way. This one here has a better edge lighting system, so you distributes the light better. You can't quite see it, but it has the same alternating LED light layout as before. Once again, we have the situation where we have an auxiliary power plug, and this one just happens to be labeled DC 12 to 15 volts. And what bothers me a bit is it does not specify tip positive, but most power adapters, unless they have a really good reason, they just automatically put tip positive and sleeve negative. So I'm going to risk it. And it's on. Even with this little 1.25 amp adapter, it still works fine. Another handy little option is this newer portable video light, mini portable LED light ML-180AI. But in any case, this is a nice little kit. What it basically is a USB power bank combined with a video light. And just to give you an idea what the size looks like, here's a Google Gen 1 Pixel. So pretty much the size of a cell phone and roughly the same thickness. Okay, so there you can kind of see the specs on it and everything. And what's really nifty about this is to charge it, you can have USB micro 5 volt in or USB-C in, and then you have a USB output to use it as a power bank. You turn it on with this little power switch up here on top, and fortunately that weird refresh you're seeing on the video right now is not happening in real life. It's just a steady display. Middle line blue indicates what our intensity is. Bottom line, also in blue, indicates what our effective color temperature is. And to cycle through those, this little dial on the side, you just push it to cycle between the two options. To turn it on is just plus and minus. And so that is quite bright. But if I dial the exposure down a bit, I can kind of see what's going on there. We have our grid of LEDs. And now if I cycle between the low end and the high end color temperature, you can actually see the grid shift from one to the other. And there it is. So that's pretty nice. And actually the brightness there, in theory, that's 1%. I'm not sure what they mean by 1, but if we go all the way up to full brightness, that is a lot of light from a little tiny unit. Since the newer light has a USB input and we have recently acquired a USB power meter, let's just do a quick test here to see if this thing actually is behaving like we think it is. It looks like just the charge circuit is pulling right around 240 milliamps, so I don't know if that's all going entirely into the electronics. I guess when it's fully off, it probably draws less because I haven't seen battery deterioration, and this OLED screen here isn't helping. But let's go ahead and turn it on and see what happens. Still looking at about the same current there, so yeah, somewhere around 200 to 250 milliamps. It looks like that's what this circuit pulls when the screen's illuminated. Okay, so here's what we're expecting. It says the LED output is 8 watts and the maximum USB input is 10 watts, which makes sense. So assuming you have maybe about 85 to 90% efficiency on the charger. So now let's go ahead and just turn it on 1% and see what that jumps up to. And just like that, about another 250 milliamps. And we're right at 4400K in the middle, which means both sets of LEDs are currently on. Now, if this thing is working like we think it is, both sets of LEDs are on, but they should be at only about half-ish brightness. We want to be able to cycle up and down without changing our luminous output. We want to go between the full range of color temperature without changing our power draw. Let's see if it works that way. So we're at 4400K, we're pulling about 0.55 milliamps. Let's go ahead and switch over and then try going all the way up to blue-white. And it looks like it's behaving. Let's go all the way down to reddish-white. Sure enough, we're staying right around 550 milliamps plus or minus. Switch over to the highest output. Okay, that's definitely up there. You'll notice we're now at about 1.7 amps and reporting about 8.7 watts. So a little under 10. If the battery was charging at the same time, then we might reach the full 10 watts, but it looks like our specs here are fairly accurate. Let's now switch between brightness. We're at 100% brightness and go over to color temperature. So I go from 4400 all the way up to still 1.7 amps and about just a hair under 9 watts. Scroll all the way down, 3200K, still about 1.7 amps and a hair under 9 watts. It is maintaining a constant output at the given brightness setting. Very useful. Has a standard 1/4 inch attachment too for tripod mounting or whatever. Also of note is that the unit is in fact magnetic. It's a good thing to keep in mind before sliding this thing in and out of your pocket if you still carry credit cards. There are other similar models out there that are more expensive, but this one here, I'm happy with it. I look at it with the exposure turned back down again, and you can kind of see now how the ones with the reddish phosphor tint on them, those are the low temperature white LEDs, and then the others are the high temperature ones. So this is a little different than the other two lights we looked at where we had an edge-lit design. This is a simple grid, but it's quite effective for what it is and very compact. You might be tempted to pick up something like this. And yes, we are still shopping at Harbor Freight. This is not a Surefire or Streamlight or one of the other nice ones. This is their little $15 Quantum light, which can be gotten for $10 with the coupon on the right months. As a flashlight, it is a nice little device. It is focusable, but if you're looking at the camera right now, you can already kind of see a problem. There's some flicker there, and in fact, if I go down to the low setting, it's even more visible, and I'm not seeing this in real life, but the camera is sure seeing it. So unfortunately, while this is a really nice flashlight, it's a terrible video light. And don't be fooled by this one with the Cobb LED panel either. This one's only $8, and again, as an area light, it's great. It's bright, or it's dim, and you can already see on the camera that yes, I was getting flicker again. This here is a relatively new product being sold by Harbor Freight. They've got this line that they call Brown, and let's just pop this open real quick. You can see that it comes with the flashlight, a USB cord, and a little manual. Now, the price tag on this one is the one sticking point. If you're trying to buy one of these brand new, $39.99. This one is worth the extra cost though because it is rechargeable. Inside here, there's an 18650 lithium cell. and it claims to be standard 2200 milliamp hours at 3.7 volts. The nice thing about this as a flashlight for sure is that it is USB rechargeable. So you just plug it into a micro USB, and after an hour or so it's fully recharged. And you might have also seen this on YouTube, particularly if you watch automotive channels, because this makes a really great work light. It also has a magnet on the end. So there's bright, dim, and then there's a little flashlight on the end here. It can be used as a video light on the bright setting. The electronics converter in here is not flickering. That isn't true for the dim setting, however. Once you go on the dim setting, depending on conditions, you can start to see some strobing. What I like about it is you can stick this thing almost anywhere. You can hang it off of say an air conditioning vent. You can hang it off of a light fixture, and away you go. This one is pricier, but if you watch the sale coupons, you can sometimes get it for 25 to 30. And all you really need to get a nice little light setup is 3 of these, and get 3-way illumination around a subject that you're trying to photograph. But there's nothing that says you have to be conventional. In fact, sometimes unconventional lights can be the easiest to spread around if you really need to. These happen to be really great video lights for 2 reasons. One is that they put out a lot of light on fresh batteries. Just make sure you swap out the heavy-duty type they come with proper alkalines. But there's another reason. These little guys are direct DC driven. There is no power converter in either of these. The DC from the batteries is a direct feed to the light, and that means there is no flicker. We get inside to our battery compartment and then finish removing 4 more screws, and we can actually look at what's going on underneath. So there we go. There's nothing on the underside of this circuit board. There's just a little resistor here which is providing a dropper for these LEDs. But the cob LED panel here is just being driven straight off the battery. And you can see there's a couple holes there for another resistor. They could have actually put in a dropper for this if they wanted. They didn't want to. And that's actually, ironically, what makes these really great for video lighting, because again, it's a straight DC source. The only thing you have to worry about is the battery slowly going dead while you're working. Of course, one nice thing about cheap is you can take a chance on modding it. So for example, this light here does have a fair amount of glare coming off of it, but with a little fine grit sandpaper, we can take a chance on just lightly scuffing up the plastic surface here in order to create a diffuser effect. Now keep in mind in doing this, we're not trying to turn it into a total fog, because if we do that, it will actually trap a lot of light inside the unit and greatly reduce its efficiency. Notice I'm using kind of rotating circular motions, that way I don't end up with just a bunch of lines in one direction. That's probably about as far as I want to take it. So turning down the exposure, we can see the difference here. Okay, so there we go. The light now is a lot more diffused, doesn't have the same hot spots that you can see coming off of this one. Still outputting similar levels of light, so still plenty bright, but more nicely diffused. Now the light being put out by that little Harbor Freight unit is in fact coming from one of these cob LED panels. Cob chip on board substrate. If I refocus and turn down the exposure, you can kind of start to see the little individual LED dies in there on the substrate. You could think about creating your own custom video light if you so desired. And a very easy and friendly way to do that is to use something like this. These are little buck or boost voltage regulators. You can order them both ways, that are widely available on eBay, Amazon, and hobby websites. They mostly come from direct import sources in China, but they happen to be good quality in my experience. The board is nice. The components are there. I mean, it's using solid state capacitors. Everything else is mostly run by this standard voltage control chip. So these actually work very well, and then you can adjust your output voltage. And the benefit of that is that if you run one of these at its full power and maximum brightness, who knows how long it'll actually last. But if you dial it down just a little bit below its ideal operating point, what'll happen is it will dim a bit, but it will produce a lot less heat and last practically forever. Let's take a look at the ring light that we're using on our bench apparatus here. That is, you guessed it, 2, 4, 6, 8 of these little guys pillaged and turned into a ring light device, fully custom for my needs. And inside this little project case here is, you guessed it, one of these. So all you need is a little project case. You can get these online as well. It's kind of hard to get them from Radio Shack anymore unless you happen to live near a hobby town, and then they still have a little bit of Radio Shack inventory on their shelf. But these little project cases are all over the place, and that's really all you need is something to put this into. Yeah, and then maybe mount a little jack, male and female pair. But if you don't care, you can just direct wire in there and solder it. So there you go. Spend a few dollars, spend a lot. There's a bunch of different ways to do it, but even a couple cheap little battery operated lights that don't, as long as they don't flicker, can be better than nothing if you're trying to make an effective presentation. So check out your options, see what you're willing to spend. Think about getting at least a couple sources that you can, put far enough back that they illuminate you without glaring, and it'll look a lot better without having to spend a small fortune on professional equipment. Thanks for coming along for this ride. See you again next time on Workshop Quick Takes, whenever that is.
Has anyone seen my phone?